Then there's a second answer to that, okay, which is distinct. But the first part is where you keep the message on the legacy line. Yeah, I mean, how does it look like on the legacy message? I'm happy to look like that.
I don't see it.
I understand.
Yeah, I don't have anything from the last 2 weeks.
So Jacob, this is Russ. I see you in the Medico room. Can you hear us?
Can hear you.
Hi. Did you send slides? Because neither Tim nor I can find them.
I did not send slides. My update is very short.
Okay.
You know, documented in last call.
I just wanted to make sure you weren't expecting something on the screen when. Good. All right.
Nope.
All right. We're going to go ahead and get started then. So, good morning, and welcome to the LAMPS group. Yov has agreed to be the Jabber scribe. We're looking for a note taker before we begin. Thank you, Rich. Are you going to do it in the Etherpad?
Yes.
All right. So everybody, if you're following along at home, please help him get the minutes right. All right. Blue sheets. We sent around one since the number of people in the room isn't that many. Please make sure you sign it. Next slide. This is the agenda that we talked about on the list. Okay. One thing to note is we were going to talk about Jim Schaad's document, RFC 5751 BIS, but it finally made it to the RFC editor's queue, so we're not going to spend any further time on it. Okay, next slide. Where's the note well? Ah, there we go. Okay. So you probably saw this a lot yesterday. Please review the note well and make sure that you comply. Thank you. All right. All right, Jacob, if you'd get back in line, we're going to hand it over to you.
All right, thanks. So real short update on RFC 6844 BIS. It went through its last call. I believe it's about to be on its way to IESG. I got a couple real small editorial fixes at the last minute from Rob. Those are in the GitHub copy. Russ, should I upload a fresh draft or should we catch those in the editor queue? What's your suggestion there?
So you sent one, you posted one yesterday.
Yep.
And I finished the Shepherd write-up based on that and sent it to the ISG.
Okay, great. So we'll just have a couple of last tweaks fixing Rob's affiliation and fixing a reference to RR sets. But other than that, it's basically a done document.
Okay, any questions? Okay, thank you, Jacob.
Thank you very much.
Okay, this document is in working group last call at the moment. Next slide. This is just a reminder of what it does. This was discussed in Montreal, and we had a exchange with Stefan, who was proposing that there might be another approach to this. He and I met after the session, talked it through, and he acknowledged that in the case where there is no problem, this one's more efficient. In the case where a problem does occur, that he had a particular edge case about, that was sorted out by rolling the key twice. And so I added that observation to the security considerations, and that's the version that the working group adopted. Next slide. This is an overview of what's going on. When you generate your first key pair, you generate the second key pair as well, and include the hash of the public key in the certificate, the trust anchor certificate. And then when you roll to the second one, you generate the third one and include its hash. So you're just staging, creating a way that the relying parties can confirm which public key to trust when they see it. Next slide. This is the certificate extension. The syntax is pretty straightforward. It's just which hash algorithm was used, followed by the hash itself of the DER encoded subject public key info. Next. We're in working group last call. As I said, security considerations were expanded based on the discussion in Montreal. Then the working group adopted it. I'm asking you, as part of the working group last call, please review it, send comments. And this is intended to be an informational document. And of course, since I'm authoring it, Tim will make all of the consensus calls related to it. Any questions? Okay, please send your comments. It's a short document. Thanks.
All right. Thanks, everyone.
Quinn, you're up next. That's the shakes.
Yeah. Since last time, it went through a working group last call, and yeah, there are only 3 slides.
Yeah.
Oh, actually 2 slides. That's the introduction. There's nothing in there.
I will go find the tech
Okay.
support guy. Keep going.
Thank you. Yeah, thank you.
Should I go? Or should I
Yeah,
wait?
no, go ahead and continue.
Okay, and when it went the first working group last call, and Jim Shot identified many issues with the documents. So we make changes to the documents to certify the comments. And right now we have several things which need comments or suggestions from the working group. The first thing we did was to replace the ECDSA with random K with the deterministic version. Yeah, and then the chairs told us to go ahead with the deterministic K version of the algorithm. And also we propose to replace the KMAC in the K generation method with the shake, because we're using the shake for the signature, so why not use shake instead of HMAC. And we need comments or any consensus from the chairs on that. Also, we replace the mass generation function in the X9 standard with the shake. So the shake now is the new MMGF. Naturally, it fits well and it works well. And also we updated the security section, security considerations. And also we pointed out the a property of the shake functions is that it's similar to like any like HMAC or SHA-512 function. For example, for the HMAC SHA-1, sometimes people use truncated outputs like 96 bits instead of the full hash function or something. And the shake has the same property. So when somebody design a protocols or looking at different protocols, and they need to take a closer look to make sure they don't have related or potential witnesses in all users in a protocol or across protocols. But mostly it's just natural deterministic function.
Quinn, can I add something there? Sure. So when Jim proposed this on the list that we use shake as the mask generation function, we asked the CFRG if there was any problems with that. They had a brief discussion, which basically everybody who read the document said, yep, that seems like a completely good fix in terms of compatibility. So then Quinn updated the document. So I just wanted to make sure everyone was aware we got the CFRG review of that idea.
Why? Oh, well, I understand. Then you can sit further up. Like, it's like, I don't want to be yelling at Quinn from the back of the room. No, I don't plan to yell at all. So I just wanted to ask about the deterministic ECDSA. I think it's fine to recommend that. I guess is there an interop impact of that? Namely, I don't believe there is, because my understanding is that the receiver has no way of validating that you use a deterministic K. But this is merely our advice on how to implement it. Maybe it's mandatory advice, but that's all it is, right?
I really did not catch all the things you said, but generation verification is the same for everything. Generation is different.
Right. So are we saying so what is this a should or a must? What did you use for the deterministic?
I think right now I would recommend to go for, if we want only one version, then just pick one, and pick one, then we have to go with a must.
Well, I mean, the fact that it's interoperable means you don't have to do either, right? I mean, as I understand it, right? So I guess my point is that, like, you have like a box which is ECDSA, and like, and generally from the implementation perspective, that box does whatever it does, and that box has like some function it uses for generating K, right? And maybe that function is deterministic, maybe it's not deterministic, and maybe you use SHA, or maybe you use AES or whatever, right? So I guess my point is that this is that everything else here is protocol interoperability and not implementation, and this is implementation. Am I wrong? I mean, so I guess I guess I'm just trying to figure out why anything needs to be done here.
The thing is, in the FIPS 186, the random K is a part of the specification originally. So if somebody wants to claim to have the compliance with the spec, then K must be generated in the way the FIP says. But right now it's K generated in different way.
But my point is, we already have another, I can't remember the RC number. We already have an RC number defining how to do deterministic ECDSA.
Yes.
And there's, to the best of my knowledge, no reason to believe that that the key generation function in that is not perfectly satisfactory. And there's no interoperability impact whether you use that key generation function or some new, like, my point is, you're now creating a new implementation of ECDSA that has no interoperability impact.
right? The verification is the same for both.
Right. So I don't
options,
understand why. I don't understand why you don't just point to the existing ECDSA spec and existing deterministic ECDSA spec and stop.
We did point it out to the deterministic version of ECDSA, the RFC. Yes.
Right. But so what is this sub-bullet need? Why do you need this sub-bullet?
In that RFC, I don't believe it provides a complete spec for ECDSA. It describes several things, but I don't think that it is a complete spec for deterministic ECDSA. It's pointed to some other standard for the spec, and then it pointed out here is K should be generated differently from the other standard.
Okay, but that's not like specifying a deterministic ECDSA is not in scope for the working group.
Nope. So basically,
if you think that spec's inadequate, then write a different spec to make it adequate.
So essentially, this section is basically pointing out to the deterministic RFC. That's all it does. And then it's right now it proposally saying instead of use HMAC, use KMAC to replace HMAC in that RFC.
I understand, but I'm saying why?
Why what?
Why are you saying anything about how that RFC is implemented?
All right, let me see if I can help translate. The RFC about deterministic ECDSA tells a way to do it. You're saying KMAC also is another way to generate that input, generate K. Eric's asking, why does the protocol document say anything about that at all? Just say use deterministic ECDSA and stop.
That's my question, yes.
But right now in RFC, it uses only the HMAC.
So?
And we think it makes sense to use KMAC instead of HMAC.
Okay, but wait a second. Like, say I have an implementation. Let's check out the entire implementation of the system, right? I have a key generation function starting with randomness. That key generation function starts like may use HMAC internally, may use AES internally, may use anything, right? It's just a PR. It's a PRNG, right? Like that uses HMAC, or is this document going to also say like stop using HMAC there? It's just none of your business.
No, okay, but that's your point of view. But I think anything if we should say something or we allow something, expect something, we should be more concrete about what people should do or should not do. For example, instead of random K, we normally say, okay, K is randomly generated, but how? This is the methods we believe we feel comfortable with, how to do random K generation. That's how we do it. But if you want to say, okay, random K and you stop there, that's fine. But for us, I would go further to say something, what
this is not about deterministic versus random. This is about implicitly updating the deterministic ECDSA spec to include a new hash algorithm, to include digest algorithm, which is not like that's not in scope. If you want to write a what is the number?
So
if you want to write an 8232 BIS, does it say 8232 specifies HMAC, I assume?
So basically,
just say stop. Just say PRF.
So right now in the documents, basically it says it gives reference to that RFC, and then it just say instead of using HMAC, use KMAC, and you seem like want me to do something different.
Yes, I want you to take that sentence out.
So that means like KMAC won't be used then?
I'm saying it is. I'm saying like, okay, I'm saying it is none of this protocol's business which function you use generate K, like whether it's KMAC or HMAC.
So you're saying if we want to use KMAC to replace HMAC, we have to update that RFC. That's all you. That's
yes,
what. Okay.
I'm saying write a BIS for that RFC, and then I think write a BIS for that RFC.
Okay, so it's a long discussion. It's ended to what you really would like us to do. Technically, they're all the same, but if the approach you want us to do,
well, no, I mean, I guess
then let the chairs, you know.
I don't think it is the same because where you've put it, it only affects SMIME. Eric's saying if you put it in the other document, it affects anybody who wants to use deterministic ECDSA.
Correct.
And that's what he says we ought to be doing.
right.
Okay.
I mean, generally, like,
correct.
yeah, I mean,
But
yeah.
but here we only deal with what we authorized to do right here.
right.
Instead
And I'm
of
saying you're not authorized to do this.
we're not authorized to do that,
Like,
to use KMAC.
you're not authorized to BIS 8032, which is what you're doing.
Okay. All right. If that's your interpretation, then I follow what the chairs and the group want us to do. It makes sense. It has its reason, good reason. So
The 8032
it's up to the chairs.
Are those
to call.
example constructions 8032 or are they specifications? I'm ready to know why. Huh? No, in 8032 says you must.
No, it's just HMAC.
No, I'm saying what is 80? I mean, like, I guess what I would like you to be able to do. Let me be clear. What I think a reasonable thing for this document to do is, I think this document ought to be like, I assume what you're attempting to achieve is a protocol implementation which does not use SHA anywhere, right? And so SHA-2 anywhere. And so I think if to the extent to which so the question I'm asking is, if you cite deterministic ECDSA, does that force the implementation to use SHA, or is that just, or is that is HMAC just exemplar?
You mean in the RFC is HMAC uses SHA-2?
But does it say that's the only thing you can use, or does it just say you should use a PRF and here's one example construction?
I think it specifically say HMAC with SHA-2.
Okay. Wait, that's deterministic ECDSA? Oh no, I'm talking ECDSA.
No, if I'm not wrong, then I think it specifically uses and says HMAC with SHA-2 something, SHA-256 or SHA-2.
Right. Well, so I mean that's so it's like it's generally unfortunate if we're citing like if we have like, again, I like to understand what the facts are, so maybe I should sit down, and we should look it up. But like, it's generally unfortunate if we're telling people to use deterministic ECDSA and that's tying them into one hash function. But that's like a problem with that specification, which we should fix. So if the objection is that nobody in the IETF can use deterministic ECDSA without using SHA-2, then we should BIS that specification and say it has to be a PRF and then give examples of the PRFs. What we shouldn't do is like attempt to piecemeal patch it here.
You have your reason. I don't see any wrong with your approach. It's just the direction and the taste the chairs want to take us from here. But do we have the authority to BIS that RFC, because that authored by somebody else, by Thomas?
That's not in our charter.
Yeah.
Okay, can we hear what the other people in line?
Informational
they've been waiting
RFC.
patiently.
Hi, Jonathan Hamill from Canadian Center for Cybersecurity. I just have a minor point about when you talk about using KMAC. Technically, KMAC uses C-Shake, in which case the security considerations don't apply because it doesn't have that problem with overlapping outputs for different lengths. So that should be clarified.
Right. You're right. It just generally we're talking about a shake alone. Yeah. Generally, we're talking and.
So Max Balak, Cable Labs. To the point that Edgar was making before, in the draft, I think now is written you must use KMAC. Could that be a may so that you can use other constructions and you don't limit? So if I want to have an implementation that is compliant, I don't have to use KMAC. And I can use something else. That would be a way to do it, but not the only way to do it.
Yeah, but that has its reason. But the thing is, when we're saying that, and then people, feel like they can use anything they want, that doesn't seem to be a good idea. You have to be specifically what you feel comfortable for to recommend people instead of say people use anything they want.
No, I understand that. I'm just saying that if you put a must, any implementation has to use that, cannot use anything else. if you use may, we can have some implementation that use other constructions that are still secure, and the verification is not a problem. It's just the way that you construct that.
That if that works for you better, then I think I have no objection to that. Yeah.
And I think that Edgar, I don't know if that work out for you. If you change
that would make your implementation a little more complex. You have SHA, and then you have SHA-2. You do K generation, and then here you do hash and everything with HMAC, with KMAC. So it makes the system a little bigger. But that's not what you want. Then I have no objection to that.
Okay.
Yeah, that's fine. I think I have nothing wrong with the HMAC with SHA-2. Nothing wrong in my understanding. It's just if you want things more efficient, then you don't want to have two different hash functions running everywhere in your application. Why you don't need both of them at the same time? We need only one of them at the same time. But it's, if you want one application with two hash functions in there, on the security perspective, I don't see any problem with them in this particular application.
Stanislav Smishlev, CryptoPro. Thank you very much, Quinn, for the presentation. I just wanted to support Eric's position that if we want to generalize the construction with deterministic ECDSA, it's definitely a good way to go only to base the document, not to include some additional ways to implement that in other protocols. So it's just a not good way to go, because we really need, I believe that ECDSA in deterministic way of implementation with KMAC, but not only there. And so if you would like to do this work of BISIN the RFC 6979, if I'm not mistaken, then I'll be happy to help if his work is needed. Thank you.
Okay.
Thank you.
Yeah, thank you. So I'm now bothered to look through 6979. So yes, it's clear it does say HMAC. So clearly any citation of 6979 would imply using HMAC. The correct fix for this is, I'm concerned about the IETF going forward. And the correct fix for this is to BIS 6979 so that it specifies, that it specifies basically any suitable PRF, and B specifies KMAC, and I don't know, has a registry or some such nonsense. So that basically the point being that what I want to do is I want to say 6979 and have that cover a variety of ECDSA instantiations with other PRFs, and not have to have everybody either say 6979, but it's also fine if you use KMAC, or 6979 with some unspecified thing. So it's the appropriate place to BIS that is CFRG. So if you I would say, I think these are completely separable. I think you can just remove the section, just say 6979, and then this document can advance perfectly well. And then when 6979 with KMAC is done, that will update 6979, and you'll be good to go.
Okay, that would be nice. But do you and the other ID have authority to BIS that RFC or no?
No, CFRG would have to do it.
Okay, so that means
we could do it, but CFRG.
You just got an offer for help. Accept it.
I don't think CFRG is going to have any problem.
No, but the CFRG is decided by their co-chairs, right?
I understand, but
and I don't know if they are going to to do that or not. I don't know. I have no idea.
If CFRG opposes the publication of 6979 with Shake, I assure you, I'm not going to approve Shake 6979 with Shake.
No, I understand the point of view, but I just don't know what future action people will.
Neither do I. But my point is that the purpose of CFRG is to evaluate if this construction is okay.
Okay.
So Stanislav Smishlev again. Alexei Melnikov is not here, but I believe that if we have any reasonable updates for RFC 6979, then I believe that CFRG will support this work, because it's really useful RFC, and it's quite good ideas to update this with using our SHA SHA-3 construction, but I don't see any reasons for guys in CFRG to not to do this work if your if you volunteer to be the one who pushes it.
I have my full support for an effort in CFRG for doing this. I'm just saying that, you know, we need the CFRG to take a look and then decide and tell us what to do.
So could you please send an email to SFRG, or maybe just raise this question in Prague? So I believe that also SFRG supports this work.
Okay, I do what the group thinks best thing to do. I do it.
Okay, thank you. And personally, I'll be happy to help with this work.
Oh, thank you in advance.
Thank you.
Okay.
Right, the next slide, I have a few questions. Yeah, we need to generate the ISN1 module for the CMS draft, and also you know, more reviews are better always. And also Jim raised a question. He asked about whether or not we should allow shorter tags for KMAC. In many cases, it makes sense to have shorter tags if you care about the size. But for security, I would go to the full size, and I feel happy about it. The bigger, the more comfortable I feel. But some of the situations, people might decide to cut down the size, and I don't know if the chairs and the working group would like to do that. Yeah, the chairs will have to tell me what to do.
I think you take Eric's advice, remove the KMAC discussion altogether, fix the ASN1 module, then we do working group last call.
Okay, so ask the FIG about the best.
That will, yes, but
that
that's
one and
a
this
fork, right? Because you're still going to reference the deterministic ECDSA RFC, and when that one gets BIST, the reference will be resolved.
Okay. So I just want to be sure I got the direction for what I should do. Is that I should add CFIG regarding to the short attacks? That I'm still confused about that.
No, you want to talk to them about supporting KMAC in deterministic ECDSA. Jim's question doesn't apply if KMAC is not raised in this document.
No, but KMAC in here, it's not using an ECDSA. It's KMAC alone by itself for CMS.
Oh, I'm sorry, I misunderstood that.
That's why I was confused. I didn't know what.
I've always assumed that this was fine to truncate.
Yeah.
But like, I'd like to see a statement from somebody that's fine to truncate. So either
Yeah.
either
Okay.
CFRG should say it, or you should have a citation that it's fine.
Yeah.
So I don't know which. If we have those things to hand, then I think it's fine. But I think like again, okay. So let me take a step back. My thesis here, both with the previous point and this, is we should have IETF-wide understanding of what constructions are fine and what constructions are not. And so I do not know if it's fine to shorten to KMAC, but we should have an IETF-wide understanding of whether it's fine. And so on what basis do we think it is fine?
It depends. You mean like short attacks? It depends on the size and the uses of the KMAC. It varies from application to application.
Sure.
It depends on application. It's
Okay.
depending on situation where you use it.
I'm designing a new protocol called like LAMPS-9, and I would like, and someone suggests I should use shorter tags. On what basis do I make the decision? And I'd like to not have to hear what I just heard from you in order to answer the question, right?
Yeah, but
it's like
that's why I said I feel comfortable with full size, but if some of the people like Jim wants to use shorter tags, and it depends on what application and where situation is in order for me to write some good recommendation. But so that's why I'm asking the group how to handle this.
I think the person behind you wants to.
Hi, Jonathan Hamill again. Can the flexibility not be put in the draft, like in the ASN.1 module, to allow a tag length to be specified, and then it's up to outside the scope, I guess, to determine what size people want to use?
That would be a fine option to me. The only thing is that I really don't want people to use too short tags. Yeah, because if they use like 64-bit tag and then they use in the high volume traffic, and that would make me feel extremely nervous. But if they use the 4 tag like that, and like in almost all of the practical applications in the world, it's still safe. But you're right. It's up to application. They decide what text size they want to use. That would be fine with me. But I would, if we did that, and I would hope to put some advice into the document saying, you know, how much traffic they should restrict depends on the text size they use. If a text size like this, 256-bit, then it seems to be good for everywhere. But if like you get to the very, very short text, then you have to be really careful about where you use it.
Not a cryptographer, but my understanding is the situation with authentication tags is roughly the same between HMAC and KMAC. Is that correct?
That's my understanding.
So what do we do for HMAC?
We just leave it to the HMAC spec.
Which has a full-length tag.
Yeah.
So I would suggest that use a full-length tag here. If someone wishes to promulgate a tag truncation mechanism, then they can promulgate that for both KMAC and HMAC. But like this seems like, since I understand the purpose of this document be to allow you to produce a KMAC only, a SHA-3 only suite, like I don't see any reason to be any different from HMAC. And I'm like not opposed to short tags, but I'm saying like let us do short tags orthogonally to KMAC versus HMAC.
Ben Kaduk, I agree with Ecker. I'll just point out that we have used truncated HMAC tags in other protocols, you know, Kuros and whatnot. So there's some level of prior art.
And IBSAC as well. It's been widely used, I think. The 96-bit HMAC. Yep. So it looks like leaving it alone 4 size for now with the document. Is that my correct understanding of the chairs want me to do?
Yep.
Okay. Any other questions or comments for me to for us to improve the documents? This is a the group's document, not my document. So you're all responsible for this.
Okay.
All right.
I hear no.
Thank you.
Else. Okay, in Montreal, we talked about hash-based signatures and using them in CMS. And then since Montreal, the working group adopted this draft, and we've had a couple revisions. Next slide. You'll know that the CFRG has been working on hash-based signatures for more than 5 years. The research group has completed their last call on McGrew's HashSig doc. Provide a bunch of things about what's going on there. The bottom line is that you have a small amount of code to validate a signature that's very can be done very quickly. However, the signature itself is quite large, but these signatures are quantum resistant. Next. So sorry, there's a typo on this slide. The MTS in the middle of this should not be there. The one application where this makes sense is for signing firmware packages. RFC 4108 describes one way to do that using CMS. And I think this is important because we want to deploy a quantum resistant signature now, so that when you want to deploy code in the future, you, if a quantum computer of significant scale comes to pass in the next decade or so, then we'll be able to validate the signatures on the code that deploys the new quantum resistant capabilities. Next slide. So some recent errors were fixed, found by Daniel. Thank you for the review. I think we're ready for working group last call soon. That is when the draft McGrew arrives in the RFC editor queue. That's what I mean by soon. It should be soon, since the research group has finished their last call. Anyway, I'm asking for review and comment now that that document seems to be stable. And once again, since this document, I picked up the pen, Tim will make all the consensus calls. Any questions? Okay, thank you.
Yes, mixed with PSK.
So following on let's be ready for quantum computers just in case. This is another solution. The idea here is to mix a PSK in with either a Diffie-Hellman or a RSA type result, so that we can, so that even if a quantum computer is invented, we have the attacker has to learn the PSK as well as break the public key algorithm. Next slide. So what the concern is that an adversary will save a content that is produced today, and then someday, and save it away, and then someday when they do get a hold of a large scale quantum computer, they'll be able to break the key management. And the solution is to mix a strong PSK with it. And then that's the near-term solution. The long-term solution, of course, is to deploy a quantum-safe public key technique. That is the winner of the NIST competition. Next. This approach that I've proposed in this document deals with two kinds: key transport, that is RSA style key management, and key agreement, that is Diffie-Hellman or ECDSA style. And it mixes a PSK in with the result of either of those techniques. Next slide. This provides an overview of how that actually works in each of the cases. In the key transport case, the originator makes up a key and encrypts it in the public of the recipient, and then both parties take that key that the originator made up and mixed it with the PSK. And in the second case, the key agreement, the sender of the message uses the recipient's public key, their private key, produce a shared secret, and that shared secret gets mixed with the PSK. Next slide. So there was a privacy observation that an observer who can watch which PSKs are being used by each of the parties can learn what groups talk to each other. I observe this really isn't making things any worse, because in key transport, the recipient key identifier, that is when the originator uses the public key of the recipient, we pass along an identifier of that key so the recipients can find which piece of CMS is for them. And in the case of key agreement, the long-term public key is put in a certificate, and either the issuer serial number or the recipient key identifier identifies the recipient anyway. So including the additional PSK identifier isn't making it any easier or harder for an attacker to learn who's talking to who.
I'm generally sympathetic to this argument, but if I had two PSKs, if I had suppose a situation where we have one recipient who has two PSKs with different people, then then you'd be able to distinguish the senders, even if even the recipient. So the recipient info, as you say, would say, I'm sending to you, but you share one PSK with me and one with Ben.
Yep.
Then in this case, you'd be able to tell, an attacker would be able to tell whether it was me or Ben sending to you. Well, it wouldn't know who it was, but it'd be saying,
right,
these messages were Ben, this message were me, right?
Right.
I don't think it's a huge crisis, but it's just
no, I don't.
one to nitpick.
That's actually, if you look at the way KEKs are handled in CMS, same situation because you're passing a key identifier. So.
Not when you use Diffie-Hellman though, right?
No.
Okay, yeah.
No.
So yeah, any symmetric
Exactly.
system has this problem. There's like no way
Yep.
around this problem.
Exactly.
Yeah. Well, you could. Now that I'm saying this, you could wrap, if you want to do a bunch of extra trouble, you could wrap the PSK identifier under encryption, under the public key encryption, and that would remove the problem. I don't really care, but
Oh, yeah. Okay, I'll have to think about that, but I'm not sure it's worth it.
it's probably too much of a pain in the ass.
Right. Given all the other things that we've all agree is true on this slide, I'm not sure it's worth it.
Hi,
Yo,
channeling Stefan Sanderson. My worry is that this turns a public key algorithm into a secret key algorithm, and thus won't work as a replacement for use of public key algorithms in most cases.
That's correct.
So following up on that, this is Daniel Kahn-Gilmore. What's the usability story here? Do you have any? I know this is the IETF. We're just working on the network protocol, but like, do you actually have a story where you can imagine this thing being deployed?
Yeah, I think it can be used in groups, and the question is how big is the group where they're all using the same PSK? And of course, the bigger the group, the more likely it's going to leak, and so on. So you got to balance those things. But the idea is that, say, the finance department could all have one PSK, and so on like that, so that they can continue to do things pretty much as they do today. And you have to roll, like any other symmetric algorithm, you have to roll the keys periodically. But that's the idea, is that then the attacker would have to get that group key as well as a quantum computer.
Okay, so here is Guiling. So I have a comment. So I understand actually how to get the PSK is out of the scope of your document.
Mm-hmm.
But my comment is that actually PAKE is a very promising message to get the PSK. Yeah. Yeah, could do it. Yeah, could do it. But of course, currently maybe not so many very good messages yet. Yeah, but possible. Actually, we have some.
Could you talk to the microphone, please?
Yeah. Okay.
My question was, do you have a post-quantum PAKE? Because if you use a non-post-quantum PAKE to share the PSK, then you're back in the soup.
Exactly.
Okay. Yeah, it's a good topic. Yeah. Actually, we have some ongoing research paper about quantum secure, PSK. Oh, no, PAKE. Yeah, PAKE. Something like a PAKE.
Please talk to the microphone, not to
but
Dan.
of course, it's not so mature yet. But we will consider this one. Yeah.
So I think the base question is, please
so
share.
anyway, this
Please
also
send
means-
us a PAKE that is post quantum, and we'll look at that too.
Yeah. So this also means maybe it is something like an open question for us. Yeah. So how to get a quantum safe PSK?
Correct.
Yeah. Maybe this can be make an announcement or something. Yeah. In security.
Because they all rely on some public key technique buried at the core.
Okay.
Yep.
Yeah. Good.
So I think this is getting really close to ready for working group last call. However, I'm concerned that there's been not much discussion on the list. So I'm pleading with you to review and comment on the list. Thank you. Oh, it's out there somewhere. Who's got the blue sheets?
Does Dan have slides?
Yeah. Daniel, we're looking for your slides.
So I think this is the using hash-based signatures X back on that.
Yep. Very good.
Oh, am I here?
We hear you.
Okay. So this draft is to add hash-based signatures to X509 certificates. It's kind of point 3 in the make things quantum safe, followed by or after the two things that Russ has presented previously. More specifically interested in HSS and XMSS. Russ's first presentation kind of went over the reasoning for it, why to use hash-based signatures. They're well studied, secure against quantum computers. Oh, sorry, you can go to the second slide. Why these algorithms, specifically HSS and XMSS/XMSS-MT, they have small private and public keys, fast signing, but large signatures and stateful. Next slide. So there's some use cases for this in X509. End entity, not really a good use case because managing state is hard. And if you fail to manage state securely, that means you could end up reusing the one-time signatures in these algorithms. And if you have a limited number of signatures, then increasing the number of signatures will increase the signature size. In interactive protocols, it's not great. You can use an HSM to manage state, and you have more control over the number of signatures, but it's okay if you can live with the signature size. The best use case for this is certs in non-interactive protocols, that is CA certs, and code signing, which Russ alluded to earlier. His first draft is appropriate for code signing. You can use HSM to manage state. You have more control over the signatures. Signature size is not so much of an issue. And the important thing is that these signature algorithms are ready to deploy now for longer lived certificates such as IoT and automotive. Next slide. So, I mean, basically this is it. This draft is going to sec dispatch later, well, for me tomorrow morning, but for you guys later today, to see what they think about it, maybe send it to LAMPS. And for us in LAMPS, is they're interested in this? Will people be commenting or reviewing on it? And just as a note, it's already been partially aligned with Russ's first draft in hash SIGs and CMS, and it would continue to be aligned with that. So comments, interest? Wait for sec dispatch.
Yeah, so I asked Daniel to talk about this a little bit here today because if sec dispatch says, oh, it comes to LAMPS, I'd rather be further along than hearing about it for the first time at IETF 104. So let's talk as though sec dispatch has said, let's send it to LAMPS and see if there's interest.
So Max Pala, Cable Labs, small question. If it's sent to LAMPS, do we need to recharter?
we probably will, and that comes to any other business on the agenda. We probably have to process a charter update for something else anyway. So yes, that would be the time to do it.
So, and this is forward looking. We have kind of a similar proposal, goes in the direction of adding the possibility to have different type of signatures and keys in certificates and many other PKIX objects. So when we recharter, maybe we can include, this type of work. That would be great.
Hi, my name's Sean Turner. And read this draft real quick. It's not that long. Basically, it's got exactly what needs to be in there to do the things to marry up with Russ's draft. So if it were to be accepted, good. It would be fairly short, I would think, discussion, hopefully leading quickly to a working group last call, because there's just not a lot there. It's ASN1 and formats that are based on RFC 59, 11, and 12. Off you go.
That's what I was hoping. I basically copied most of your text, Sean.
That's what we do. You owe him a beer, I think he said.
In Prague or Montreal?
Cheaper in Prague.
Much cheaper.
Okay, any further comments or questions? Okay, thank you.
Thank you.
Okay, there's one other bit of any other business that has come up since we published the agenda, and that is Alexi stopped me in the hallway yesterday and said, hey, I presented that thing in Montreal about header protection, and then I wrote a draft. Can you adopt it? And I said, no, we can't adopt it till we do a charter change. And so we had some email discussion with Ecker, pointing him to what was going on. And so, Eric, would you support a charter change in that direction?
I guess I have two preliminary questions. One, do the chairs feel like they have the working with the bandwidth to take this work on?
Yeah, I think it's a pretty straightforward document.
Okay, and the second is, do people in this working group understand what this is about, and do they want to do it?
That is exactly the question.
If the answer to both of the questions are affirmative, then I support this.
Okay.
This is DKG. So I've offered to co-author the draft with Alexei. I do think it's important. I think it is a travesty that we actually don't have this stuff widely implemented. I'm also working with other folks who are mail user agent implementers who have implemented header protection that is working between multiple user agents today. That's simply in a mechanism that is not documented here. And I think the header protection draft that we're working on is going to work for both PGP-MIME and S-MIME with the same mechanism. And so, yeah, so I fully support this.
Bernie Hoenhuizen. I'm here speaking for the PEP, Pretty Easy Privacy guys. We have about 4 implementations that use header protection, but in a way that is more or less the standard way now, like encapsulating the whole message into as a MIME attachment to the normal message, except that this forwarded equals no is not yet there, of course, because it's new. But if this is going forward, we would just implement that as well, because it's a useful feature for the presentation. And we would also support this work to go forward, hopefully in our way.
I wanted to hear this round first. Sure. Okay. So after Alexei posted the pointer to his individual draft, how many people read it? Okay, 5, 6 people. And if the work was to be taken on by this group and ultimately lead to an RFC, how many people would implement it? 2 for sure. All right. There's some of the big mail vendors are not in the room to say one way or the other. So.
So I'll just say that there are multiple implementers who are already implementing it. Okay. So in the event that we don't document it, that'll be fine. It'll just be documented somewhere else. Right. But it's kind of sad if the IETF working group that's supposed to be dealing with the way that email works can't document the things that people are actively doing today. So those folks aren't in this room necessarily, but there are other implementers.
You get them to at least speak up on the list to that able to do it?
Yes, I can. I spoke with several folks. There was an OpenPGP summit about a month ago where there were people, there were about 24 people, many of whom are mail user agent implementers, and there was active interest in it. And yes, I can get more people to participate. I don't know that I can get them all on the LAMPS list. We'll see. But yeah.
Fair enough.
So, yeah, to be clear, my standard here is like, there are enough people to work on it that will deliver a useful document, and enough people implement it to make the document useful. And if the mailing list demonstrates those 2 things, then I'm supportive of doing it.
Okay. So again, in the any other business section, does anyone have something to raise?
Sorry, can I just can I get a sense of what the next steps are in order to consider this as a recharting? Because I want to report back to the folks that I spoke to at the OpenPGP Summit so that I can give them.
We're going to draft some charter text and then send it to Ecker.
But I would like to see.
I understand, but that's the next step. And so the discussion of that charter text is the next thing you'll see on the list. And so then people can say, yes, that looks good to me, and yes, I will implement it. That is what Eric wants to see in order to.
Okay, but so in terms of like a timeline, if folks are doing this, people are going to be, people are already working on this. There are already implementations. So I'm just trying to make sure that I can report back to them in a way that they're not going to be like, oh, so you're telling me wait 2 more years and then there will be a spec and I'll implement it then. No, I mean, I know it might happen. I've been at the IETF for a while. Like I've seen the process.
So chartering takes 2 to 3 months.
Yeah, I mean, this can be recharted in 2 months if you start the discussion list now. I mean, the hard deadlines are, it'll presumably take you a couple of weeks to like deal with it, and then it has to do a 2-week IETF last call, and it has to be a telechat. So you're looking at like 6 to 8 weeks. But we can, if people do the right things, we can do it then.
Okay, so the recharting takes time, and we can, and Alexia and I will be working on versions of the draft which will remain in the
as
individual drafts for now.
Correct.
Okay.
Yeah, and that part can go as parallel. Okay. No one else having any other business for the group? Thank you. We're done. Did everyone sign the blue sheet? Okay, thank you.
I was going to not show up. Until he said that, I was just kidding.
You caused trouble and then now you show up. KMAC tag length. I know, but I didn't know that was going to cause a blow. So we'll be sending the CFRG some